Hello everyone, welcome to Gate Academy. Good evening all. Yes, please tell me audio video clear or not. बताओ ऑडियो वीडियो का बारे में क्लियर आर नॉट. Good evening everyone. Shiva Prasad, good evening. Yes, clear, very good. Nishit, good evening. Okay, all of you like this session, like and share this session. Like तो बनता है ना. Like करो, share करो. Okay, to reach maximum aspirants who want to learn electrical machine from Bhanu sir. Namaste. Namaste Dilip. Very good. Manish, hello. Okay, so let's discuss our session. In previous session we had discussed about operating principle of the generators and motors, and also working of the generators and motors, and after that we had discussed about torque equation, EMF equation of the generators and torque equation of the generators here. So this part we have discussed in the previous sessions. Today we will discuss about the constructional details of the DC machines. Okay, have we clear now? Okay, is it visible all of you? Okay, so now see here, constructionally there is no difference between the generators and motor. That is a one machine can be used as a generator as well as a motor. That means एक machine को हम generator का use कर सकते और motor का भी use कर सकते. So here but the difference क्या है? The difference, the way of input is given to the machine. So if the input is given as a electrical energy, then machine act as a motor. Okay, if the input is a mechanical energy, then the machine act as a generator here. Okay, all of you clear my point? So constructionally there is no between the generator, there is no difference between the generators and motor. The one machine can be used as generator as well as a motor. So what are the main parts of the generators? Okay, and what are the main parts of the DC machine here? So we have a majorly, like suppose any rotating electrical machine has two major parts. So what are the two major parts? One is the here all of you. So any rotating electrical machine has two major parts. So one is the stator. Okay, stator part of the machine, and second one is the rotor of the machine. So what is the mean by the stator and the rotor? The stator means the stationary part of the machine. Okay, this is the stationary part of machine. So that is known as the stator of the machine. Okay, so these are the in any rotating electrical machine, the rotating electrical machine, the majorly it has the two parts. One is a stator part and other one is the rotor part. Okay, the stator in the sense stationary part of the machine, whereas a rotor is the rotating part of the machine. Okay, this one is the rotating part of machine. Got it? The stationary part and the rotating part. So now question is, what are the stationary parts and what are the rotating parts? Clear point? So what are the stationary part and what are the rotating parts? The stationary part of the DC machine. Okay, this is the stationary part of the DC machine. One is the stator frame. Okay, this is the stator, the frame, and it is also called another name of the stator pole, स्टेटर फ्रेम. स्टेटर फ्रेम को हम अदर नेम से भी बुला सकते हैं. दैट इज द योक ऑफ द मशीन. ओके, दिस इज द योक and it is another name, it is also called that is a magnetic frame of the DC machine. Okay, all are same, the stator frame, yoke or magnetic frame. Okay, these are the stationary part of the DC machine. And second one is a pole core. Okay, this is also the one more stationary part of the DC machine. Okay, and third one is a pole shoe also, that is a stationary part of the machine, the pole shoe. And the fourth one is a field winding. Okay, there is a winding, two types of the winding. So one is a field winding and armature winding. The field winding also in the DC machine. Okay, especially in the DC machine. What are the stationary parts? So one is the stator frame, it is also called yoke, magnetic frame, and pole core, pole shoe, and fourth one is a field winding of the machine. And fifth one is a brushes also. Okay, brushes are also treated as the stationary part of the machine. Okay, now coming to the rotating parts. So what are the rotating parts of the DC machine? Okay, so these rotating parts, okay, first part is a armature core. Okay, this one you can say that armature core. So that is the rotating part. And second one is a armature winding. Okay, this is the armature, the winding of the DC machine. And third one is a commutator, is the stationary, the rotating part of the DC machine. So in the complete, so these are the some parts, these are the rotating parts, okay, of the DC machine, and these are the stationary parts. Okay, this one is the stationary, the parts of the DC machine. Okay, clear my point? So what are the rotating parts? Armature core, armature winding, and commutator. And what are the stationary parts? The stator frame, pole core, pole shoe, field winding, and brushes. Okay, all of you clear my point? Is that clear, everyone? Yes or no? So this is a stationary, all the parts of the DC machine. But what about the question, और क्वेश्चन कैसे पूछते हैं कंस्ट्रक्शन ऑफ द डीसी मशीन में? ये पहले क्वेश्चन क्या है? द नेम ऑफ द मटेरियल टू कंस्ट्रक्ट द सम पार्ट. फॉर एग्जांपल, द नेम ऑफ द मटेरियल टू कंस्ट्रक्ट द स्टेटर फ्रेम. दिस इज द वन पॉसिबिलिटी ऑफ द क्वेश्चन. एंड सेकंड वन इज द फंक्शन ऑफ द स्टेटर फ्रेम in the DC machine. Like so, but here this part is a very important in this case. So in the DC machine, so this part, armature winding, is a very important part. So we can expect the 2 marks question from the armature winding, but remaining all are 1 mark point of view important. So from only armature winding there is a possibility to ask the 2 marks question. But remaining all are function of the stator frame, function of the pole core, function of the pole shoe, field winding, armature, field winding, brushes, commutator, armature core. Okay, these are the all main parts of the DC machines. Okay, so now coming to the here, so we have a one DC machine. Okay, like suppose this is our the DC machine here. So in this case, okay, have we clear this part? Is it visible? आपको दिख रहा है ये पार्ट? ठीक है विनोद, हिंदी में पढ़ाऊंगा, बस कोई दिक्कत नहीं मुझे हिंदी बात करने के लिए, लेकिन फ्लो नहीं बनते ज़्यादा। आपके साथ बात करूंगा, बिल्कुल हिंदी में बात करूंगा, लेकिन आप पढ़ने टाइम में एक फ्लो रहते तो थोड़ा इंग्लिश में ज़्यादा रहते। आप कुछ भी क्वेश्चन हिंदी में पूछो, मैं बता दूंगा हिंदी में पक्का, मुझे कोई दिक्कत नहीं हिंदी बात करने के लिए। लेकिन एक सब्जेक्ट का फ्लो है ना, थोड़ा इंग्लिश में थोड़ा कंफर्टेबल है, सिर्फ इतना है। आप मेरे साथ हिंदी में बात कर सकते हैं अच्छे सा, मैं आपको जवाब भी देंगे हिंदी में। जूम करना है क्या? अच्छा ठीक है। सो नाउ टेल मी, आपको दिख रहा है पार्ट? अरविंद, यस आई नो, तेलुगु, हिंदी, इंग्लिश तीनों लैंग्वेज में कंफर्टेबल है मैं। आप कुछ भी सवाल हिंदी में पूछो, तेलुगु में पूछो और इंग्लिश में भी पूछो, कोई दिक्कत नहीं मुझे बात करने के लिए। ओके, आपको दिख रहा है ये डायग्राम? Yes, okay, see here. So this part you can say that, okay, here. So this one is a stator, okay, part, okay, stator of the machine. So this is the stator part, and here we have shown this, okay, like this, listen. So this one is the stator part, okay, and this is the pole shoe, okay, this part is a pole shoe here, okay, pole shoe, and this the red color we are show इधर दिख रहा है ना रेड में, so ये है फील्ड वाइंडिंग है, so ये पार्ट है आर्मेचर रोटेटिंग पार्ट, okay, this is the armature core of the DC machine, okay, and here brushes are, okay, this one is a the here. Here this is the commutator, okay, this is the commutator of the machine, okay, and brush है ना, ए पार्ट को बोलते हम ब्रश, okay, this is the red color में ए है इधर, so this is the armature winding of the machines, okay. Suppose let us take one more diagram, so this is a, so exactly the this part, okay, is it visible now? Okay, so this is a complete a stator, okay, this is the yoke of the machine, okay, yoke, and here, okay, this part we can say that commutator of the machine, and okay, this one is a, okay, here आपको दिख रहा है इधर, so a pole core, and here pole shoe, okay, this is the shaft, so shaft means this one is the shaft of the machine, and here, okay, this is the armature winding of the machine, so this winding is a the field winding of the machine, okay. So this is the diagram point of view. I will show you, I will draw the one construction, the cross sectional diagram of the DC machine, okay. How do we draw? Listen. Okay, so let us draw the stator frame. Suppose, okay, this is a the complete the stator frame, okay. So all the poles are, okay, this is the stator frame, and poles are fixed to the here stator frame, okay, like this. Okay, so next one, so this pole structure like, okay, one pole and other poles, okay, like, so this is a chamfered poles, that's why we can draw like this, okay, it is a poles. So now where is the field winding? Okay, field winding is a, suppose it is a one terminal of the field winding. Field winding is placed on this, okay, line. Okay, this is a the field winding of the DC machine. Okay, agar the field winding either, okay, this is. So now it is excited with the DC supply. Okay, it is the VDC here. Okay, so now current passes to the field winding. Which current passes here? So that current is the DC nature of the current, positive supply and the negative supply. So when it is current passes, suppose current entering position and this one is a current leaving position. So what will happen? According to the right hand thumb rule. So if it is a circular conductor, right? So if the orientation of the fingers indicates the current direction, so then thumb indicates flux direction here. So flux lines are, okay, these are the flux lines, okay, all the flux lines are. So this is the direction of the flux, and here also flux lines are, okay, like this. So that here all the flux lines, okay, passing from, so this is a one pole to the another pole. So this pole act as a north pole, okay, this is the act as north pole, and this one is act as a south pole, okay, like this. So here flux lines are coming from north pole to the south pole, and this is coming back to the north pole like this. So this is the direction of the flux in the stator frame. So it is the first part, okay, stator frame here. And next one, so we have the armature core. So how do we draw the armature core? See here, all of you. So this I am drawing armature core, okay, like. So this is the armature core. All of you got it? So this one is a armature core of the DC machine. Okay. So this armature core, conductors are placed in the armature core. So how do we place the conductors? See, all the armature conductors are so placed in the armature core. Okay, like this. Okay, this is a one conductor, okay, second conductor and third conductor, like so on. Okay, so this one is another conductor. Okay, all the conductors are the placing like this. Okay, it takes some time, just wait. Okay, all the armature conductors. Okay, so these all are armature conductor. So this part we can say that armature core. So next one we have a commutator. Okay, that where is the commutator here? So this is a commutator part. So in between here, okay, this is the commutator part I have drawn. So like, so this part is a commutator. Okay, so this commutator is divided into the commutator segments. So this is a one commutator segment, second commutator segment, all the commutator segments like this. Okay, here. So finally there is a shaft. Okay, where is a shaft here? So we have shown this shaft. Okay, okay, this is the shaft of the machine. Okay, so it is a constructional, okay, cross sectional, the area of, okay, DC machine, or cross sectional, okay, cross sectional the of the DC machine. Okay, if you see the one end, so these are the all parts. Okay, this part we can say that the stator, okay, frame of the DC machine. Okay, this is the stator frame. All of you clear point? So now this part wherever we are placing, okay, हम इधर winding place किया था ना, so a winding को here this winding you can treat it as a field winding of the machine. Okay, field. So now this one, okay, this pole structure you can say that, so it is a pole core of the DC machine, and this one is a pole shoe of the machine. Okay, it is a pole shoe. And where is the armature core? So this is a armature core of the machine. Okay, armature core. And what about this one? I have mentioned this dotted line. So these are armature conductors. Okay, here armature conductor. So these all armature conductors are, okay, this is a armature conductors. So connected to the commutator segment, okay, like, so these all commutators are connected to the commutator segment, like so on. So like this, all are connected to the commutator segments, okay, like, so these two are connected to the commutator segment, okay, like this one. So all the commutators here, conductors are connected to the commutator segment. So this part we can say that, okay, it is a commutator of the machine, okay, commutator. So now where is the brush position? Okay, brushes are so placed on the commutator, okay, this is the, so brush is a placed on the commutator, okay, listen this point. So here this is the brush are placed in the commutator like this, okay, here brushes are placed. All of you clear point? So shaft of the machine, okay, this is a the shaft of machine, and okay, this part we can say that the brushes of the machine. So it is a cross sectional view, okay, cross sectional, so view of the DC machine. Is that clear now? Yes, I will tell you everything, what is the functions, just see the diagram. So that is the exact diagram. So it is the one end, okay, अगर हम एक डायग्राम को इस तरफ देख रहा है ना, ये complete, okay, this part, okay, this one. So that is a cross sectional view of the DC machine. ओके, इज दैट क्लियर माय पॉइंट? आपको समझ रहा है? ओके, सो नेक्स्ट वी विल डिस्कस अबाउट फर्स्ट पार्ट. सो दैट इज द स्टेटर फ्रेम ऑफ द डीसी मशीन. सो इट इज द स्टेटर फ्रेम, ओके. सो हाउ डू वी ड्रा द स्टेटर फ्रेम? ऑलरेडी वी हैव ड्रॉन दिस पार्ट, ओके. सपोज वी हैव टेकन so this part. So here so stator frame of the DC machine. So now we have a question, what is the name of the material to construct the stator frame and what are the functions of the stator frame? So stator frame is a made with, okay, this is the stator frame is a made with cast steel material. So this is the stator frame, okay, it is a made with the cast steel material. So this is a cast steel for small rating of the machine, small rating of machine, okay, and cast iron, okay, for large rating of the machine. Okay, we have a two ratings, so large rating as well as the small rating. For small rating, which material is a use? Cast steel, and for large rating, cast iron material is a use. So what is the small rating? So the rating less than or equal to 5 HP. So that is the small, the rating of the machine here. And what are the functions of the stator frame? So it has a three functions. So one first function is a, so it acts as, okay, outer cover or protecting cover for entire machine. All of you got it point? So first function is, so it act as, okay, this act as outer cover, okay, or protecting cover, okay, ये protect कर सकते. So here is a protecting cover or outer cover of entire machine. So this is the protecting cover the for entire the machine, okay, this is a, so first function of the stator frame. and second one is a, so it provides the, okay, this one is a, it provides mechanical strength to the field poles. So what is the mechanical strength to the field poles? Suppose field poles are, okay, these are the field poles, right? So field poles are fixed to the stator frame. So in this diagram, so we have the field poles, okay, like suppose this is the north pole, okay. So these field poles are the revolted to the stator frame, okay, this is. Suppose here also another poles, okay, like so on. So field poles are the revolted to the stator frame. So suppose let us assume this is the north pole and south pole is there. So what will happen here? So these flux lines are passing from, so north pole to the south pole, okay, this is the with outside the magnet. So inside the magnet, flux lines are passing from south pole to the north pole, okay, like. So it provides the mechanical strength to the field poles. Next function is, so it provides, okay, or it gives mechanical strength, the strength to the field poles, okay, mechanical strength to the field poles, got in point. And next one is a, so it provides the return path, okay, it provides the return path for the flux line. So this is the flux here, so it provides the low reluctance path to flow the flux. So that's why you can say that, so it provides, okay, return path, okay, this is the return path for flux, okay. These are the three functions of the stator frame. I already mentioned that the stator frame is also called the yoke of the machine, or it is also called, okay, this another name. So it is a magnetic frame. Why it is a magnetic frame? So flux lines are, it provides the return path to flow the flux. So that's why it is treated as the magnetic frame of the DC machine. Okay, is that clear now? Mechanical strength, that's correct. So in case of the DC machine, stator frame has three functions. One is act as a protecting cover for entire machine, and second one is it gives the mechanical strength to the field poles, and third one is it provides the return path for the flow of the flux. So is that clear my point? Yes. So next one, let us discuss about, so that is a, so third one we will discuss, third part or second part. So that is a pole core, okay, pole shoe and field winding. Pole core, pole shoe and the field winding of the DC machine. So where is the pole core, pole shoe and field winding of the DC machine? See here all of you. So where exactly occurs here? So this is a one, the north, this one pole have taken. So it is a, so it is a pole arc, okay, pole arc. So this is called as the pole arc. That means the distance between the two edges of the poles, that is a pole arc. And this part we can say that the pole shoe. So it accommodates the pole core. So next one, this the pole shoe here, pole core, okay, this is the structure of the pole core like this. Okay, so now where is the field winding? The field winding is placed like one turn, okay, second turn and third turn, okay, like the number of the turns. So it is excited with the DC supply. So DC nature of the current passes to the field wind. So this is the field winding of DC machine, and this part we can say that the pole core of the machine. Okay, so like pole core, pole shoe and the field winding. Okay, is that clear now? Yes. So now pole core is made with. So what are the name of the material to construct the pole core? And what is the name of the material? Pole shoe. And what is the name of the material to construct the field core? So field winding. So first we will discuss one by one. So that is a pole core. Okay, pole core is made with the solid steel. Okay, that is a solid steel material. So that means no laminations are required. Okay, this is the no laminations are required in the pole core. Okay, and this is a solid steel material, and pole shoe is made with, okay, this pole shoe. So it is made with the cast steel material. Okay, this cast steel, and it should be laminated. Okay, that is a laminated to reduce eddy current losses. Okay, this is the to reduce eddy current loss or eddy the current losses of the machine. Okay, so what is the mean by eddy current loss? Already we have discussed that part in the transformers. So eddy current losses is nothing but wastage of the power in the form of the heat. So due to temperature rise in the magnetic core part, that is known as a eddy current loss. So now here is one is a laminated and other one is a no lamination is a required. Why? I will tell you that part. क्यों ऐसा क्यों होता है? So pole core is made with a solid steel material, and pole shoe is made with a cast steel material, and it should be laminated to reduce the eddy current losses. And next one, the pole shoe. Okay, this is the field winding of the machine. So what is the field winding? So it is made with copper, so or aluminum material. But preferable is the copper is prepared. Okay, this is the copper is prepared here. So next one, what is the nature of the field wind? Okay, this is the pole core. So pole core accommodates the field winding. Okay, pole core field winding. So pole core में place करता है. So here pole core accommodates the field winding and act as a electromagnet when the field winding is excited with the DC supply. Okay. So what is the function of the pole core? See here. So this pole core, okay, accommodate the pole accommodate the field winding and act as a electromagnet. The electromagnet when field winding is excited with DC supply. Got it point? So when the field winding is excited with the DC supply, it acts as a electromagnet. So that flux lines are passing from one pole to another poles. So as shown in the first figure, see here, all of you have shown. So when field winding is excited, what will happen? So this is a current entering position and this one is a current leaving position. So now according to the right hand thumb rule, okay, orientation of the fingers indicates the current direction, thumb indicates flux direction. So that flux lines are passing from one pole to another pole. So pole core function is it accommodate the pole core, okay, accommodate the field winding, act as an electromagnet when field winding is excited with the DC supply. So for small rating of the machine, the permanent magnets are used. For large rating of the machine, electromagnets are used. Okay. So next one, what about the pole shoe here? So pole shoe accommodate the pole core. Okay, this is the pole shoe. The accommodates. Okay, pole shoe accommodate the pole core and provides mechanical strength. Okay, provide some mechanical strength. Okay, mechanical strength. The two poles, the pole core, strength to the pole core. All of you got it point? Suppose a pole core or mechanical strength to the field winding of the machine. Okay, field wind. So why I will tell you, listen. Suppose just assume this is the pole core. Okay, here my left hand is a pole shoe. So windings are placed on the this limb. Okay, windings are placed here like this. Suppose if there is no pole shoe, what will happen here? So here under running condition may chance to get this winding fell down. so which is undesirable. That's why pole core accommodate the field winding, okay, and act as an electromagnet when field winding is exert the DC supply. The pole shoe accommodate the pole core and provides the mechanical strength to the field winding. Otherwise what will happen? So field winding गिर जाएगा under running condition में, okay, which is undesirable in the machine. Okay, is that clear now? Okay, next coming to the here. So what about the nature of the field winding? Sometimes we have a question, the nature of the field winding of the machine. So field winding is a concentrated type. Windings are two types basically. So one is a concentrated winding and second one is a distributed winding. So distributed winding is used in the armature winding. So nature of the armature winding is a distributed winding. So nature of the field winding is a concentrated winding. So the क्या होता है concentrated winding मतलब क्या है? So that means total number of the turns are placed at particular distance or single slot of the core is known as the concentrated type winding. So nature of the field winding is the field winding is a concentrated winding. And what about the function of this field winding? So field winding, okay, when the field winding is excited with the DC supply, so this creates the steady nature of the magnetic field. So this is the function here. So it creates, okay, steady nature of, so steady nature in the sense the DC nature, okay, nature of the flux or nature of the magnetic field. So which is the DC nature of the flux is required. Okay, is that clear everyone? So what is the function of the pole core, pole shoe and also field winding of the machine? So now question coming to the here. So there is a one of the question in the interviews. So why pole core is not laminated and pole shoe is laminated? So what is the reason? So actually pole shoe is, okay, here this pole shoe. So as the here some slots are provided in the pole shoe. So in this case, okay, windings are provided. This winding is known as the compensating winding. Okay, so compensating winding is placed in the pole shoe of the machine. So which is connected, okay, this is a connected, so in series with, okay, this is the in series with the armature winding. So definitely what will happen, the current flows here. So nature of the flux in this case, the flux is a AC nature of the flux in the pole shoe, and flux in case of the here pole core is a DC nature of the flux. So I have mentioned that eddy current losses occur in the any magnetic material, so due to its finite value of the conductivity. So whenever time varying nature of the flux is passing through it, so if the flux is a DC nature, then what will happen, there is no eddy current losses. So here flux in the pole core is a DC nature of the flux and flux in the pole shoe is a AC nature of the flux. So that here there is a possibility of, okay, so this is the some possibility of the eddy current losses. How do we reduce this eddy current losses? So it can be laminated, okay, like this. Okay, these are the all laminations are provided. So these laminations are provided in the pole shoe but not in the pole core. Okay, is that clear now? Pole core, pole shoe and field winding, very simple. So question point of view, only question point I am telling this one. First question is name of the material to construct the part and what are the functions. The pole core is made with a solid steel material which is not laminated. Why? Because flux in the pole core is a DC nature of the flux. The pole shoe accommodate the compensating winding, so which is used to neutralize the armature reaction or which is used to improve the commutation process in the machine. So what is the mean by armature reaction, commutation, we will discuss later. So but compensating always placed in the pole shoe, so which is connected in series with the armature windings. Okay, so this is exactly structure. Suppose here this one is a one pole shoe, okay, like so pole shoe here, okay, this part, and this one is the pole core. Pole core is a solid structure and pole shoe is a laminated structure, okay. Compensating winding, I will tell you about the compensating winding whenever we have a discussion about the armature reaction effect. So that is one of the method to neutralize the armature reaction effect. So compensating winding is always placed in the, okay, pole shoe, okay, this it is placed, okay, placed in, okay, pole shoe, okay, pole shoe, and connected in series with armature winding, in series with armature winding here. So what is the nature of the current in the armature winding? Okay, this current in the armature winding is the AC nature of the current. So current in this is the compensating winding also AC nature of the current. So definitely which flux is created here? AC nature of the flux. When flux is the AC, there is a possibility of eddy current losses. How do we reduce this eddy current losses? By laminating the core. But here flux in the pole core is the DC nature of the flux. There is no problem of eddy current losses. That's why no laminations are required in the pole core. But laminations are required in the pole shoe. Yes, have you got it now? So मेगर माई टाइमिंग्स द सुबह 11 बजे ट्रांसफार्मर का क्लास है द डे एवरी डे एंड इन द इवनिंग 8 PM DC machines का क्लास. Yes, okay. So now coming to the here one more part. So that is a armature core. So third part we will discuss about armature core. Okay, so this is a very important discussion. Listen. So armature core is what is the name of the material to construct the armature core? This is one of the question. And second question is the functions of the armature core. Okay, so armature core is made with, okay, this is a armature core is made with the silicon steel material, okay, silicon the steel material, and it is laminated, okay, it is laminated, okay, to reduce eddy current losses, okay, similar way the laminated to reduce eddy current losses, okay. So why because the current in the armature winding is a AC nature of the current. So that flux produced in the armature is a AC nature of the flux. So that there is a possibility of eddy current losses in the armature core also. So how do we reduce this armature core eddy current losses? So that eddy current losses can be reduced by laminating the armature core. So first one, it is made with silicon steel material and it is the laminated to reduce eddy current losses. And second point here, so what are the functions of the armature core? So we have the two functions, the majorly one is, so it accommodates, okay, this one is accommodate armature winding of the DC machine, okay, this is the accommodate armature winding of the machine. And second function, okay, so it provides the low reluctance path, okay, this is so it provides, okay, low reluctance path. So this is the reluctance path. So to flow the main field flux, reluctance path per, so main the field flux, okay, that's why flux lines are so passing from one pole to another poles, okay, this it provides the low reluctance path, so from one pole to the another poles. Suppose we have so this is the diagram. So what will happen? So all the flux lines are passing from the south here north pole to the south pole. So if it is it provides a high reluctance, then what will happen? No flux coming from north pole to the south pole. So this armature core provide the low reluctance path per the main field flux. Okay, that is the one of the reason. And second reason, so it accommodate the armature winding. Armature winding the pole core में use pole core में place करता है. Yes, the stamping pole, that is also one of the reason to neutralize armature reaction. Stamped poles. Okay, next one more is so pole core. Okay, this is the, have you seen this diagram? So it is this one is a slots, okay, slot, and this part is a slot edges, okay, this one is the teeth, okay, teeth up here. So what is the exactly slot and teeth here? Suppose we have okay, like this is the pole core. So it is the divided into the so it is a design with the slots, okay, like this. So 1 slot, 2 slot, okay, 3 slot, 4, 5, 6 and 7 slot. So now here is the slots are provided like this, okay. Okay, this is the slot area. So now this is known as the slot. Okay, this part you can say that the teeth, okay, teeth of the machine. So windings are placed in the slot. Suppose here the windings are placed in the slot, okay, like so armature winding conductors are placed in the slot, okay, like this. So armature conductors are placed in the slot, okay, this is the slot and the teeth. So now question is, which type of slots are prepared? So actually, so we have 3 types of the slots. Okay, one is so open type slots. Okay, this is the open type slot, and second one closed type slots. Okay, third one is semi-open type slots. Okay, these are the type of the slot. Okay, in the any electrical machine. But in the DC machine, which type of slots are prepared? This is also one more question. Which type of slots are prepared? There is a question here. So which type of slots are prepared in the DC machine? Okay, in the DC machine here. Now tell me, which type of slots are prepared in the DC machine? What is edge? Okay, that's correct question. Edge means here in this diagram. So there is a slot is designed, okay, like this. Okay, it is so slot is okay, this is called the slot edge. Okay, slot edge. Okay, it is a slot, and okay, this part you can say that slot edge. Okay, this part. Okay, so these are all are one mark questions. So which type of slots are prepared in the DC machine? Tell me. बताओ आप. Which type of slots are prepared in the DC machine? Answer it. We have 3 types of the slots. One is a open type, semi-open type, and or semi-closed type, or one more is a closed type slots. So which type of slots are prepared in the DC machine? Open type. Amit given open type. Not semi-open. Semi-open type slots are prepared in the induction machine. Okay, this is a, so semi-open type slots are prepared in the induction machine. Okay, and this open type slots are prepared in the DC machine as well as the and synchronous machine. So practically this is the closed type slots are not prepared. So what is the reason here? Suppose if the slot is a close, okay, suppose this one is a close like this. So here there is a it is a very difficult to insert the conductor into the closed slots. But it is a open, then you can place the conductors directly into the slots. But if it is a close, we have to insert the conductor into the slot. So that the placement of the winding is a difficulty in the closed type slots. That's why we cannot use these slots in the any electrical machine. But in the induction machine, there is a one reason I will tell you whenever we have a discussion about the induction machine. The semi-open type slots are prepared. Okay, but in case of the synchronous machine and DC machine, so that is the open type slots are the prepared. So what is the reason here? So DC machine is the main function of the DC machine is designed at the time of designing. So we have to think about the commutation. So open type slots are prepared in the DC machine to improve the commutation process. Okay. So this part, okay, open type, the slots are prepared in the DC machine, to improve the commutation process here. So how does we can improve the commutation process? So that is in case of the open type slots, okay, in case of the open type slots, what will happen? Listen. So that is a leakage flux is a very high in case of the open type slot. When the leakage flux is a high, the leakage reactance will be high value here. So due to which what will happen? So leakage reactance is high. So then we can reduce this reactance. One of the reason to get the delayed commutation in the DC machine, the reactance voltage. So that reactance voltage can be improved, okay, can be neutralized by using this leakage reactance. So that's why it is a open type slots are prepared in the DC machine. Suppose if in the synchronous machine, so synchronous machine is in the stability point of view. So VE by XL, the sine delta L. So as this is the leakage flux in the machine. So this is the low value, leakage flux is a low. So okay, so leakage flux is a low in case of the open type slots. So leakage reactance is a low, and therefore the reactance is also low, so that you can improve the commutation process. So now in the stability point of view also, so leakage reactance is a low, then what will happen? The stability can be improved in case of the open type slots. I repeat once again, listen. So when in case of the open type slots, so this leakage flux is a low value. When the leakage flux is a low, the reactance is also low. When leakage reactance is low, reactance voltage is also low. So when reactance voltage is low, you can improve the commutation process. So in order to get the delayed commutation in the DC machine, the reactance voltage is also one of the reason. So to reduce the reactance voltage, so this is a open type slots are prepared in the DC machine. Yes, that's correct. In the synchronous machine also, the stability is the main criteria. So in order to improve the stability of the synchronous machine, open type slots are the prepared. Okay. So next one, another part, the fourth one here is a commutator. Okay, listen. So commutator structure is means initially there is a armature core, okay, like this. So it is a armature core. Okay. So next one, commutator is a provided like this. So this commutator is a divided into the slots. Okay, like so on. So this one is the commutator. So this is the divided into the small parts. Okay, listen. So this part you can say that the commutator part. So commutator is a rotating part of the machine. The first point here, so it is a rotating part of the DC machine. Okay, and second one, it is a made with hard drawn copper material. So the drawn copper material. Okay, so this copper material to reduce the wear and tear losses. So wear and the tear losses. Wear and tear losses means, what is the wear and tear losses? Tear means to avoid the breaking. Okay, wear means to reduce the surface area of the. So in order to prevent the reduction of the surface area, or in order to prevent this breaking, so that's why it is made with hard drawn copper material. And next one, it is a rotating part of the machine. So it is not a solid structure. Okay, this one is, so it is not a solid structure. So this is so here it is divided into, okay, divided. So here this is the divided into the here commutator segments. So here each commutator segment, okay, this is the commutator segment, the insulated by, okay, this is the insulated by, so mica insulations. Okay, this is a mica insulation. Sometimes we have a question, which type of insulations are. So if we see the diagram here, so this is the armature part, okay, armature, and all the conductors are connected to the commutator segment. So here is this part, you can say that the commutator segment. Okay, here, okay, this is the commutator. So now each part, okay, is insulated by some mica insulation. So this is the here, this part, the mica insulation part. So now conductors are connected to in this all the commutator segment. Okay, like this. Okay. So now it is not a solid structure. So it is divided into the commutator segment. So each commutator segment is insulated by mica insulation. And next one, we have a question. So that is a number of the commutator segment. So what is the number of commutator segment? So number of commutator segments always equal to, okay, this number of the commutator segment. So that is equal to, so number of the armature coils. Okay, how many? Suppose coils are 32 coils are there. How many commutator segments are required in the commutator? 32 commutator segments are required. So this is also one more possibility of the question. So number of the commutator segment, and it is divided into the commutator segments, and it is made with the hard drawn copper to reduce wear and tear losses. So now what are the functions of the, okay, this is the functions of the commutators. Okay, this is also one of the possibility question. So first function, in case of the generator part, okay, already we have discussed. So in case of the generator, it converts AC current to the AC to the DC current and act as a converter. Okay. Now in case of the motor, so commutator converts DC to the AC and act as a inverter. Okay, this is so one function. So this is the first one. So in case of the generator part, okay, so it converts, okay, this is the converts it is the AC to the DC, and act as, okay, converter here. Okay, this is the convert. And in case of, okay, motor point of view, so what will happen? So it is in case of the motor, so it converts, okay, converts the DC to the AC and act as the inverter. Okay, this is the another two functions here, the in case of the generator and in case of the motors. Okay, so we have it, the all the possible 1 mark questions here. So there is no possibility of the to ask the 2 marks question, but 1 mark point of view. So name of the material, okay, commutator segment, number of the commutator segment, and also functions. So it has a 2 functions, one is the generator point of view, another one is a motor point of view. Okay, right. So next one, let us discuss brushes. Okay, brushes part. So brushes are stationary part of the machine. Okay, first point here. So brushes is the stationary part. It is not a rotating part. Okay, stationary part of the machine. So here, suppose, listen here. So these are my all the armature conductors. Okay, conductors are connected to the commutator segment like this. Okay, this is the so here brushes always make contact with the commutator segment. Okay, this is the when commutator is a here armature is a rotated by the frame mover, commutator will be rotated, but brush is a fixed to the stationary part. Okay, so it is always make contact with the commutator segment like this. Okay, this is a so Arclin point. This is my armature conductors. Okay, armature, and this is a commutator part. All the armature conductors are connected to the commutator segment as shown in the this as shown here. So now brush is a okay this part. Okay, brush is a fixed to the stator frame. When armature is a rotating, whenever armature core is rotated by the prime mover, then what will happen? Commutator will be rotated. But brush is a stationary, but it always make contact with the commutator segment. So to collect the current from the commutator segment and deliver to the load in case of the generator. And in case of the motor, what will happen? If there is no contact, okay, with the commutator segment, what will happen? It seems to be like open circuit. So no current flows through the armature conductors. Yes or no? So this the brush, okay, commutator part. So we have shown the commutator. So this box are, okay, these two are the brushes of the machine. Okay, it is a brushes. Okay, so now we have a question like the name of the material to construct the brushes and what are the functions of the brushes in the DC machine. So here brushes are made with, okay, these brushes are so made with the copper, okay, copper or carbon material. Okay, carbon the material. So per small rating of the machine. Okay, this is the small the rating of machine. Okay, small rating of the machines. So next one, so it is also that is a electrographite, the graphite for normal rating of the machine. These are the 3 questions. Normal, the rating of the machine, and next one that is a copper graphite for large rating of the machines. Okay, large the rating of the machines. Okay, these are the materials. So what is the name of the material to construct the brushes? So one is a copper or carbon for small rating of the machine, and electrographite for normal rating of the machine, and copper graphite for large rating of the machine. And what are the functions of the brushes here? So we have a 2 functions. So in case of the generator, what will happen? The brush collect the current. Okay, brush collect the current from the commutator and deliver to the load. Okay, so in case of the motor, the brush collect the current from the source and deliver to commutator segment. So that is exactly reverse function. So that what is the first function? That is in case of the generator point of view. So what will happen? The brush, okay, the brushes collect the current from this from the commutator segments. Okay, from the commutator segment and deliver to, okay, this is the delivered to the load. Okay, this is a one function. And in case of the motor point of view, so what is the function here? So this brushes collect the current from the collect current, so from source, okay, and deliver to this is the deliver to the commutator segment. So these are all functions of the brush, okay, and in case of the generator and in case of the motors. So now what are the name of the material to construct the brushes, and is it a stationary part or rotating part? Always brushes are stationary part. So now the material is copper electrographite and copper graphite. So for small rating, normal rating and large rating. Have you got it now? So these are all 1 mark questions, no need to expect the 2 mark question from this, but theoretically it is a very important part. 1 mark point of view you can expect the questions. So tomorrow there is a winding, armature winding part. So that is a very important part in the DC machine. Okay, so now we have a questions, some questions here. Let us discuss the questions, all theoretical questions. So first one, armature core of the DC machine is laminated to minimize. So tell me this question, all of you. Armature core of the DC machine is laminated to minimize. Armature core of the DC machine is laminated to minimize which one? Answer it fast. Easy question. Armature core is laminated, okay, to reduce the eddy current losses. So that eddy current losses means, okay, this eddy current loss. So it is a I square R loss. Okay, this I square R, the loss in the magnetic core. Okay, this is the magnetic core. How does it occur? Suppose, so here eddy current loss, okay, directly proportional to, current is directly proportional to the square of the conductivity. The resistance is inversely proportional to the conductivity. So now these two will be cancelled out. Then what will happen? So eddy current loss directly proportional to the conductivity of the core. Okay, this is the conductivity of the core. So suppose we have taken two materials, okay, like, so one is a laminated material and the other one is unlaminated material. So this is a one it's not laminated, it is a solid steel. Okay, this one is a laminated steel. Okay, then what will happen? Listen. So laminated steel means, so we have a provided laminations like, okay, first lamination, okay, second lamination, third lamination, like so on. So each laminated part, okay, insulated by some amount of the insulating materials. Okay, so now already I have mentioned that eddy currents in the means what? What is the meaning of eddy current exactly? Suppose eddy current means circulating current in the core. Okay, circulating current. Suppose we have a one example point. So there is a river. Okay, it is the river here. So water flows from this case. Okay, for example, so water flows in the river. Okay, it is a, so A point to the B point. Okay, in a river. So water flow in a river. Okay, water flow in the river. So what will happen? So always suppose A point to the B point. So but here some amount of the water in the river, so circulating at only one point. Okay, this is okay, like circulating, so one other. So this water is known as the eddy water. Okay, like eddy water here. So similar way, when current flows here, okay, when current the passes to the this core material, some amount of the current, okay, circulating, okay, within the core. So circulating within the core. So this current is known as the eddy currents. All of you clear point? So what is the meaning of eddy current here? Suppose if you take the example water flow in the river. So क्या होगा इधर water flows from the one point to other point. For example A point B. So water flows from A point to the B point, but some amount of the water circulating within the river. So that is known as eddy water. Similarly, some amount of the current in the core circulating within the core. So that is known as eddy current. So power loss due to this eddy current is known as a power loss due to this eddy current in the form of heat, okay, is known as eddy current power losses. So now here is this is the circulating current, okay. So now here area occupied by the current is a more. So next one, the here where is the more, so definitely resistivity, the resistance of the core will be the less. So when resistance is the less, okay, conductivity of the core will be high. So when conductivity is a high, so then what will happen? So eddy current loss directly proportional to the conductivity. So now here is the circulating current within the core. So is a area occupied by the current, okay, area by current. So now this is the less, okay, when area is a less, what about the resistance here? The resistance of the core will be high. So increase in the resistance of the core decreases the conductivity of the core. So as the conductivity is a decreases, okay, eddy current losses will be decreased. So that's why, so in order to reduce the eddy current losses, laminations are required, okay. But it is only eddy current losses occurring. So if the flux is so definitely flux should be time varying nature of the flux. So if the flux is a DC, there is no eddy current loss. What is the reason? If the flux is a DC here, so now EMF induces in the core will become 0. So if there is no induced EMF, definitely no eddy currents, okay. Yes, okay, see here, whenever flux flows in the magnetic material, okay, actually property of the magnetic material here, so it has high value of the permeability, okay, this is, and the low value of the conductivity here. So that means the magnetic material also act as a conductor with small value of the conductivity. So whenever time varying nature of the current, whenever time varying nature of the flux passes to the core, then what will happen? Some EMF induces in the core. So this EMF, okay, gives rise to the circulating current within the core. Okay, this circulating current, so current in the form of heat due to temperature rise is known as eddy currents. Okay. So this is about this question. Question is a very simple concept point of view. So what is the eddy current? Okay, and everything. So next one. So one more question, answer it. Riser. Where you can use? Ask the complete question. Ask me complete question, then I will answer it. So which one commutator segments are made up of? So commutator segments are made up of hard drawn copper material. Okay, what is the reason here? So to reduce, okay, this is the to reduce the wear and tear losses. Okay, wear and the tear loss. Okay, wear means the reduction in the reduction in surface area. Okay, this is the surface area of, okay, area, and tear means it is a breaking. So in order to reduce these two effects, it is made with a hard drawn copper material. Okay. Next, there is one more question. It is a important question. We can answer this. A commutator of the DC machine can provide, okay, this is a can provide half wave rectification, okay, provide full wave rectification, and convert AC to the DC, convert DC to the AC, provide control pull wave rectification. So options are given. From these, correct statements are option A 2, 3, 4, option B is a 1, 2, 3. So 2, 3, 5, okay, 2, 3, 4, 5. 2, 3, 4, 5 or 1, 2, 3, 2, 3, 5. What is the answer? Suppose already we have discussed in case of the generator point, okay, in case of the generator, so it converts AC to the DC, right? So in case of the motor point of view, okay, motor, so it converts, okay, the DC to, okay, this is the DC to AC. So here AC. So what about the rectification point of view? Already we have discussed in case of the working of the DC generator. So current in the armature coil IA is equal to, so it is a positive of one positive cycle and first half rotation. So in the first half rotation here, current flows in the armature coil, okay, like this. So this is the AB conductor. So AB, okay, CD, याद है आपको? So already we have discussed this point. So in the first half rotation here, the current flows from A to B, okay, and C to D. So in the first half rotation of the conductors. So in the second half rotation here, so B to this is D to C and B to A. So that exactly here. But current in the load, okay, this is the current in the load. So that is the only P to Q terminal. And here also P to Q terminals. Okay, just refer here working of the generator, working of the generator part. We will know it. Already I have discussed this part. So here P to Q here. So what it means? Half cycle here, full cycle is rectified. Okay, this is so what we conclude here, commutator is the rotating uncontrolled. We cannot control this current, control the output. So that's why commutator can be treated as, that is the commutator, okay, this is the commutator. So in the DC machine, okay, in DC machine is treated as, how does it treats, that is so it is a commutator in the DC machine is treated as, okay, treated as, so uncontrolled, okay, uncontrolled, okay, pull wave rotating rectifier, rotating rectifier here. So this is a uncontrolled pull wave, the rotating rectifier. That is a exactly function of the current. So now coming to the here. So first statement is provide pull wave rectification. Okay, pull wave rectification here. So next it is not mentioned are controlled or uncontrolled. So next one, the provide here control pull wave rectification, that it is not correct. So now here is the convert DC to the AC. Okay, it is a correct in case of the motor. So convert AC to the DC. Okay, this is also is correct in case of the generator. So next one, provide pull wave rectification, provide half wave rectification. So it is not half wave rectification, it is a pull wave rectification, but is a uncontrolled. Okay. So that answer for this question is, so only 2, 3, 4 are correct. Very good. That option A is a correct. So next one more question. This in DC machine, iron losses occur in the yoke, pole core, pole shoe, armature core. From these correct statements are, iron losses means iron loss, that is equal to hysteresis loss the plus eddy current loss. Yes, that's correct, Dilip. Now tell me this question, in DC machine iron losses occur in. here for two conductors we got, suppose in this question, so this is the only for two conductors, okay, two pulses are there, okay, per how many conductors? Per two conductors. Suppose if I place n number of the conductors, that means pure DC nature of the current can be obtained across the output terminal, okay, across the output. So then what we have to do here? We have to place the more number of conductors in the armature. So that means it is not a pulsating DC. Definitely it is a DC, the pure DC only exactly on the output, but that can be obtained by placing more number of the conductors in the armature. So here only example point I have taken only two conductors. That's why how many pulses in the output here? Two pulses. Suppose if I place the n pore conductor, how many pulses here? So that is a 4 pulses, okay, like, okay. Suppose if I place n number of the conductors, definitely will get the pure DC nature of the current. So this DC can be improved by placing the more number of the conductors in case of the generator. Okay, now tell me this question. What is the answer for this question? In DC machine, iron losses occur in one is a yoke, pole core, pole shoe, armature core. From these correct statements are 1, 2, 3, 4, 2, 3, 4, 3, 4, 1 and 2. So first to verify the losses, suppose this type of question is given. So what we have to do? So what is the nature of the flux here? Okay, nature of the flux in the yoke is the DC nature of the flux, okay, and flux in the pole core is also, okay, DC nature of the flux, and flux in the pole shoe is okay, this is the pole shoe is a AC nature of the flux. Flux in the armature core is the AC nature of the flux, okay, got it point? So when flux is the DC, so this is iron losses are equal to the 0. Okay, iron losses are equal to 0. So now flux in the DC, okay, that is there is no iron losses. Okay, so now flux here, okay, in this case iron loss not equal to the 0. Okay, here. So flux in the AC, iron losses are not equal to the 0. So when iron losses are not equal to the 0, so in order to reduce, so that's why laminations are required. Laminations are required. Got it mind? Okay, laminations are the required. And iron loss are not equal to the 0. So definitely, so laminations are required to reduce. Okay, this is the exact reason. First one, so we have to verify the flux. Okay, verify the flux in the material. So if the flux is the DC, there is no iron losses. So flux is the AC, there is a possibility of iron losses. So that laminations are required to reduce or to minimize the iron losses. Okay. So now tell me here in this case, so from the iron losses occur in pole shoe and armature core, but not in the pole core and the yoke. So that answer for this question is so 3 and 4. It's not 2, 3, 4, that's not correct. It is a previous IAS question. So what we have to do here, any name of the material is given, first to verify the flux, whether flux is a DC or AC. So flux in the yoke here, which flux flows here? Only DC nature of the flux. And here flux in the core, DC nature. Flux in the pole shoe, AC. Flux in the armature core, AC nature of. When flux is the AC, there is a possibility of iron losses. So that laminations are required. Yes, have we got it? Suppose we have a question, another possibility of the question, see here. for small rating of DC machine, the rating of the DC machine, okay, brushes are made up of, brushes are made of, okay, made up of. So options are given: copper material, copper, and option B carbon, okay, option C the electrographite, okay, electrographite, and option D copper graphite. Okay, now tell me the answer. Copper, carbon, electrographite, and copper graphite. All are one mark questions, okay, are very important theoretical point of view. Copper or carbon, electrographite or copper graphite. What is the answer? Copper graphite. So here mentioned that the rating is a mention. So which rating here? The small rating of the machine. So already I have given for small rating copper or carbon. So there are the two options. Copper also given. Okay, copper दिया था, carbon भी दिया था. So लेकिन कैसे आंसर करेगा ये क्वेश्चन? Copper graphite is it per large rating of the machine, not per the small rating of the machine. So here carbon brushes are prepared, okay, per small rating of the machine, per small rating of machine. So which brushes are prepared? So that is a carbon brushes are prepared as compared to the copper brushes. What are the reasons here? So one reason is a carbon is a self lubricant nature, okay, due to which which one frictional losses can be reduced, okay, and one more is a carbon has high resistance as compared to the copper, so that you can improve the commutation process, okay. So that means first reason here, the small rating of the machine, carbon brushes are prepared, okay, brushes are the prepared, okay, prepared. So due to, okay, following reasons, okay, first reason is, okay, following reasons. So first reason is a the carbon is a self lubricant nature, okay, lubricant, okay, lubricant nature, so that, okay, so here frictional losses can be reduced, frictional loss that can be reduced, okay. So this is the first reason. And second one is a, so carbon has high resistance, okay, it has the high resistance, okay, high resistance here. So as a resistance is a high, so what is the commutation period? TC in the sense, so that is the commutation period. So time taken to reversal of the current in the armature coil. So TC is equal to L by R. So as a resistance of the brush is a high, so then definitely commutation time will be reduced. So when commutation is reduced means what? So commutation can be improved. Okay, this is the improved. So by using this brushes here. Okay, like, so this is a commutation can be improved. Okay, two the reasons. So here options are given like this. Okay, copper and carbon is given, but so which option is the suitable here? Carbon brushes are prepared as compared to the copper. So per small rating of the machine, what are the reason here? So one is it is a carbon, it is a, okay, it is the self lubricant nature, so that the frictional losses can be reduced. And second reason, it has high resistance, the so that, okay, here the commutation period can be reduced and thereby the commutation can be improved. No. Actually, voltage drop is a more definitely, but we can improve the commutation as compared to the drop and commutation. Commutation is a more preferable. The commutation is a main criteria to design the DC machine, and stability is the main criteria to design the synchronous machine. Carbon has a high volt, brush drop is a very small, 1 volt per brush. So we neglected that brush drop. Very small. So there is no problem about the brush drop. But by using this carbon brushes, so it is a mechanical losses can be, frictional losses means mechanical losses can be improved. Mechanical losses can be reduced. And one more is a commutation can be improved. That's why you can use the carbon brush as compared to the copper brush. Okay. So next one more question. For large rating of the machine, rating of the DC machine, okay. So brushes are made up of, brushes are made of okay, dash. Okay, options are same, that is a copper, option B carbon, and option C electrographite, and option D copper graphite. So here direct question this one. Okay, per large rating of the machine, so which one is used? Copper graphite brushes are used. Okay, this is the copper graphite. So now same question here. Okay, suppose, so in DC machine, in the DC machine, the brushes are made up of, okay, this is another possibility of the question. So same option, so that is a copper, and option B carbon, okay, option C the electrographite, okay, and option D is a copper graphite. Okay, this is the copper graphite. Now tell me what is the answer for this question. So these are the three possibility of the question based on the brushes. Here in this question, per large rating of the machine, already have mentioned that, okay, per large rating के लिए the copper brushes use करते, लेकिन here rating नहीं दिया था. Okay, rating क्या है here नहीं है. So we don't know what is the rating of the machine. In DC machine, brushes are made up of dash. Copper or carbon only for small rating, not for the general. Carbon and copper used for copper brushes or carbon brushes are used for small rating of the machine. Okay, suppose if the question given like this, so here we don't know the rating. If rating is not mentioned, okay, if rating is not mentioned, we have to select the material, we have to select the brush, the brushes per normal rating point of view. Okay, so if rating is, okay, rating the is not mentioned, okay, not mentioned, so in the question, okay, not mentioned, so then, so we have to select the brush, we have to select, so select the brushes, brush material, so brush material for normal rating point of view. Okay, that is a normal, the rating point of view. Okay, this normal rating point. So per normal rating, what is the answer for this question? Electrographite. Okay, these are all possibility question from the constructional part. There is a one more part we have to be discuss, armature winding. Okay, अभी तक armature winding का बारे में हम डिस्कस नहीं किया था, लेकिन कल डिस्कस करेंगे. A very important part, armature winding of the DC machine is just like heart of the DC machine. सेकंड क्वेश्चन में रेटिंग है ना, पर लार्ज रेटिंग, ओके दिस लार्ज रेटिंग, इधर रेटिंग नहीं है, सो पर नॉर्मल रेटिंग पॉइंट ऑफ व्यू वी हैव टू सेलेक्ट. सो ये पहले एयर लार्ज रेटिंग, इट इज अ कॉपर ग्राफाइट, देयर इज नो डाउट एट ऑल. सो इसमें रेटिंग नहीं है, सो दैट्स व्हाई वी हैव टू सेलेक्ट द ब्रश पोजीशन पर नॉर्मल रेटिंग पॉइंट ऑफ व्यू. सो ऑलरेडी आई हैव मेंशन दैट. सो स्मॉल रेटिंग ब्रशेस आर मेड विद द copper or carbon per small rating, electrographite for normal rating, okay, copper graphite for small large rating. So if rating is not mentioned in the question, so we have to select the brush material per normal rating point of view. So that answer for this question is a electrographite. Very good. Thank you very much. We'll meet tomorrow morning at 11 a.m. Again, we'll discuss about the transformer part. So these are all theoretical questions, but we don't want to neglect theory part also. So problems starts from the construction details, that is the armature winding, types of the generator and types of the motor. These are the three areas to and speed control. So these are the 4 areas to get a problems in the DC machine. So don't neglect the theory part also, that is a very important, you cannot miss the single mark. थ्योरी भी पढ़ना है अभी, अगर 1 मार्क क्वेश्चन सॉल्व करने के लिए थ्योरी भी इंपॉर्टेंट है. सो 2 मार्क्स क्वेश्चन कम्स फ्रॉम द आर्मेचर वाइंडिंग, ओके, एंड टाइप्स ऑफ द जनरेटर, ओके, टाइप्स ऑफ द मोटर्स, ओके, these and speed control. So these are the 4 areas, okay, to get a 2 marks question or problematic type numericals. And also basics of the DC machine also will get a some numericals and theory part. Yesterday we have discussed that part. In pole shoe, AC or DC? In pole shoe is a AC. What is the reason here? In a compensating one winding is there, one more winding, that is a compensating winding. Compensating winding is used in the DC machine to neutralize the armature reaction effect. So this compensating winding is placed in the pole shoe, which is connected in series with the armature winding. Okay. So see here, compensating winding is placed in the pole shoe, which is connected in series with the armature winding, so to neutralize the armature flux. Suppose what is the current in the armature winding? AC nature of the current. So that the same AC nature of the current passes to the compensating winding also. So definitely which flux is produced in the pole shoe? AC nature of the flux. But in the pole core, so there is no, okay, here pole core, field winding is there. So field winding is excited with DC supply. So which flux is present in the pole core? DC nature of the flux. Okay, thank you all, thank you very much. So good night all.